Hi everyone, in this video I'm going to show how to integrate the function of exponential using the appropriate substitution, meaning that here I have 8 examples. Those examples involve exponential function, and then we are going to integrate those functions by substitution. Let's consider the question A. For the question A, I'm going to represent the u as a 1 plus e power of 3x. Why I do so? Because I see that the du dx is going to have 3e3x. So the e3x here, I can substitute it with the combine with the dx, e3x, and combine with the dx can be substituted as a du over 3. From this statement, I bring up the dx to the right. I got the e3x dx, and the 3 I bring to the left. I have du over 3. So this makes me think of this e3x dx. It can be substituted as a du over 3. And the 1 plus e power of 3x here, I can substitute with the u. This one is substituted with the u. Okay, so now we can see that our question, we have successfully planned everything, meaning that everything already can be in terms of u. So now we can start to write it down. Integral, you must follow, and e3x dx is going to be du over 3. And the over 3 here, I'm not going to put it here. I will bring out the 1 over 3 as the coefficient. And the 1 over 1 plus e3x is going to be the 1 over u. So basically now we have a question 1 over 3, integrate 1 over u with respect to u. To integrate 1 over u with respect to u, we have a log u. And because of this indefinite integral, we have to plus constant c. And the final answer, we're not going to leave it in terms of u. We actually need to substitute back the u as a 1 plus e3x, 1 plus e power of 3x. And I'm going to put this in the modulus because I want to make sure this is always positive. Okay, so this is the answer. For the question B, we can write it into this form. Ex multiplied by 1 plus ex, and this is power of 1 over 2. So we must find the appropriate u so that we can substitute this in terms of u. For this question, I choose the u to be 1 plus ex. If you choose u to be 1 plus ex, later on this is going to be u. And when you find the du dx, you will have ex, right? So the ex, you can bring up the dx, you have the ex dx, this is going to be du. Because in my question, I have an ex, I have my dx. So these two combine, it can become du. So I know that later on, my question will become integrate ex dx is going to be du, and this is going to be u, right? So I have my integrate u to the power of 1 over 2 with respect to u. See, so from the complicated question, complicated function, I have make it become so simple to integrate. Just integrate using the basic rule of integration. Integrate u power of 1 over 2, you just increase the power of 1 over 2 by 1, meaning that you add this 1 over 2 by 1, that is 2 over 2, you have a 3 over 2. And don't forget to divide by 3 over 2. Then you have to plus constant c because this is not involved the lower limit and the upper limit. Then now we're going to simplify this over 3 over 2, meaning that we can bring up the 2, and you have a 2u power of 3 over 2 over 3. Final answer should be in terms of x. So this u will replace back by 1 plus ex power of 3 over 2. This is over 3 plus c. For this question C, I'm going to assume that the u equals to 1 over t squared. Why I do this? Because I can see that if I find the du dx, I will have a negative 2, because this can be written as e power of negative 2. So differentiate u with respect to, this is not du dx, this is du dt, because the variable here is t. So when I find the du dt, meaning that I differentiate u with respect to t, I bring the negative 2 to the front, and the power of negative 2 will be decreased by 1. You got a negative 3. When we simplify, we can see that we have a negative 2 over t cubed. So I see something over t cubed in my question. So here, if let's say if you let u equals to the 1 over t squared, meaning that later on your over t cubed here got chance to replace in terms of du. So it means that my choice of u is correct. So here now I will find ways to replace the 1 over t cubed dt in terms of du. So how can I do that? I will leave the 1 over t cubed at the right, bring the dt over to the right, and the negative 2 I bring to the left. I have a du over negative 2. Means that later on in my question, 1 over t cubed dt is going to be replaced by du over negative 2. Alright, so this I will circle up with the red circle. So this is a 1 over t cubed dt. This is a 1 over t cubed dt. This is going to be du over negative 2. And this e power of 1 over t squared, 1 over t squared is going to be u. So you can see that my whole question has become all in terms of u. E power of u. This become e power of u, and the 1 over t cubed dt is going to be replaced by du over negative 2. So I write it down du at the end of my function integral, and the negative 2 I will bring to the outside to become my coefficient. So here finally end up I have a negative 1 over 2, and we need to integrate eu with respect to u. Negative 1 over 2 as the coefficient, we just copy down. Integrate eu with respect to u is very simple. We just get back our eu and plus constant c. Okay, so that u we have to replace back by the 1 over t squared. So replace it by 1 over t squared plus constant c. So this is my answer. For this question, the u has to be e power of 2x plus x squared. Why we do so? Let's find the du dx. You can see. Okay, to get the du dx, we're going to differentiate the e power of 2x. We have 2 e power of 2x, and differentiate x squared. You got 2x. If I factor out the 2, I will have this. So what you can see here is e power of 2x plus x, and this appeared in my question. And meaning that if I find the e power of 2x plus x dx, how can I get the dx? Because the dx I bring up to the right, and the 2 I bring to the left, I got du over 2. This means e power of 2x plus x combined with the dx, it can be replaced by du over 2. So done our session, this part. And e power of 2x plus x squared, we already set it to become the u. So now you can see that my whole question now can become all in terms of u and du. This becomes du, so I write it down the du at the end. And the 1 over 2, again, I'm not going to write as du over 2. I will bring the 1 over 2 as a coefficient, bring out it, okay, from the integral. And this e power of 2x plus x squared, we have set it to become the u, so it becomes 1 over u cubed. Alright, don't forget, this is a 1 over e2x plus x squared to the power of 3. So when we write down in terms of u, it becomes 1 over u cubed. Now this function becomes so easy for us to integrate. Just bring up the 3, you will see that this function actually can be integrated by the basic rule of integration. Integrate this, you are going to increase the power by 1, you get -2, and divided by -2, plus constant c. Then follow with the simplify. I have a 1 over -4. The u is going to be u square. Alright, so the u we are going to substitute with the e power of 2x plus x squared. E power of 2x plus x squared. And the whole thing is square plus constants. For the question E, we have this. Now you may pause my video and guess which is the appropriate u to be substituted, and later on you can see my solution. Alright, now for this question, I will let my u equals to e power of 3x minus 1. Alright, I will take the denominator as my u, because the du dx, I got 3e power of 3x, where the e power of 3x here appear in my question. So here, why I choose this u, because when you find u dx, I see the e power of 3x. Means that the e power of 3x here, later on, it can be replaced in terms of du. How can I do that? I bring up the dx to the right. I have my e power of dx, e power of 3x dx. And then the 3 I bring to the left, I have du over 3. This means e power of 3x dx here is going to be replaced by du over 3. And the e power of 1 over e power of 3x minus 1. Okay, 1 over, because this is as a denominator, so it will be 1 over e power of 3x minus 1. Later on, it's going to be u. Now, I'm going to write it down all in terms of u. So this is a du over 3. The du, you put it at the end. And the 1 over 3, you bring it outside as a coefficient. 1 over e power of 3x minus 1 is going to be 1 over u. So now you're going to integrate 1 over u with respect to u. Don't forget to copy down the coefficient, 1 over 3. Integrate this, you will have a log u plus c. And the u has to be replaced back by the e power of 3x minus 1. This is the final answer. Again, pause my video and try to guess what is the appropriate u to be used. This question will let u equals to e power of 3x plus 2. Du dx, when you use substitution, you're going to set your u, and the next step should be your du dx. Alright, so find your du dx, you have a 3e power of 3x. After I find the du dx, I see e power of 3x, meaning that the e power of 3x, now it can be replaced by in terms of du. Okay, how can I do that? I bring up the dx, okay, and the 3 I bring to the left. So you can see that the e power of 3x with the dx, it can be replaced by du over 3. And here you have a 1 over e power of 3x plus 2 square. It's going to be 1 over u square, because this is going to be replaced by u. Now everything in terms of u, it will become like that. Du over 3, again the over 3 will be bring out as a coefficient. And this one become the 1 over u square. Once you have this function, we can rewrite this into the form of the u power of -2. So you can see clearly that this can be integrated by the basic rule of integration. Basic rule of integration meaning that you have to increase by the power by 1, you get -1, and divided by -1. Then plus a constant. After that, going to differentiate, you have a -1 over 3, and u is going to put it as a denominator. So the u now is e power of 3x plus 2. This is what you set just now. Alright, and plus constants. Question G is similar to the question that I showed before, just like similar to this question C. Because for the question C, I just let u equals to the power, and similar to this question, if you have a question in this type, you're going to let the u equals to square root of x. Let u equals to square root of x. Why we do this? Later on you will see I got my du dx as a 1 over 2 x power of negative 1 over 2. And if I simplify, I will have this 1 over square root of x. So very obviously that we can see 1 over square root of x over here. Combined with the dx, I bring out the dx. And this side, at the left hand side, I have a 2. I move the 2 to the left hand side. I got 2 du. So you can see that the 1 over square root of f with the dx, it can be substituted as a 2 du. And e power of square root of x, the square root of x here, I'm going to substitute with u. The 3 here, we can just factor out because the 3 is a coefficient. Then you have e power of u, substitute this as a u, and this 1 over square root of f dx will be replaced by 2 du. The 2 I will bring out. This is multiply. Alright, and finally we have a 6. Integrate eu with respect to u. Integrate eu with respect to u, you have an eu plus c. Then after that, substitute the u back to the square root of x. You have the answer 6e square root of x plus c. Let's look at the last question in this video. This is question H. We have a question 12x squared multiplied by 2 power of 4x cubed plus 2. The exponential function is 2 power of 4x cubed plus 2. So here is a question by substitution. When we're going to integrate by substitution, look at the power. We have a 4x squared plus 2. If we let u equals to 4x squared plus 2, when you differentiate du dx, you will get the 12x squared. So 12x squared is just nice. You have here. You have it here. You can see the 12x squared is in your question. So the appropriate u will be 4x cubed plus 2. Alright, after you set your u, you're going to find the du dx as a 12x squared. So you can see that the 12x squared is here. You combine with the dx, it can be substituted as a du. I bring up the dx, I got 12x squared dx. So 12x squared dx, it can be replaced by du. Alright, so here I said that this can be replaced by du. And the 2 power of 4x cubed plus 2 will be replaced by 2 power of u. So now I'm going to write down everything in terms of u. So what I circle with the red line here will be replaced by du. And this one will become 2 power of u. So now we're going to integrate 2 power of u with respect to u. So follow the formula. According to the formula, we're going to copy down the exponential function and over log 2 plus constant c. Then finally, we're going to substitute back u with the 4x cubed plus 2. And the log 2, we just copy it down plus constant c. This is our answer.